Hello, welcome to this Chapter 13 probability review video. Let's quickly walk through some of the different types of problems we'll do here. So we'll first talk about combinations and permutations, and then we'll look at permutations with repetition and circular permutations, and then we'll look at some basic probability involving combinations, and then some of the dependent probabilities or probabilities that are compound. And then we'll look at conditional probability, which is when you're given one event and looking for a probability of another subsequent event. So right away, I'll just kind of start off looking at the first question: how many ways can 6 teachers be assigned to teach 6 different classes if each teacher can teach any class? So how this is going to work then, this is a permutation. Since the order is going to matter in which the teachers can teach the classes, there are 6 teachers. So there's 2 ways that I can do this. I can either just say simply 6 factorial, meaning 6 times 5 times 4 times 3 times 2 times 1, or I can look at this like it is a permutation of 6 choose 6, and you're going to end up with the same answer for both of these, and that's going to end up being 720. So there's 720 different ways for that to happen. How many ways can 6 different books be placed on a shelf if the only dictionary must be on an end? So out of the 6 books, we're going to assume that one of those is a dictionary. And what that means is that I have my 5 remaining books in the middle of this. So another way I could say this is 5, 4, 3, 2, 1. I can look at this as saying, hey, there's a bunch of different ways that I can arrange these. Basically, there's 5 factorial ways that I can do that. Because again, it's 5, 4, 3, 2, 1. And what it does is, if I have my end book here, I have 5 factorial ways. Now what happens is that means that there are 120 different ways that I can organize those 6 books. But if I move my dictionary to the other end, it adds on another 120 different ways. So there's 120 ways the first way, 120 with the second. So really, I'm going to end up with 240 different ways to arrange these books. Next one. So from a choice of 3 meat toppings, 4 vegetable, how many different 3 topping pizzas could be made? So if I just name 3 different toppings, the order doesn't matter. And because the order doesn't matter, that implies that this is a combination. Now there's 3 meat, 4 veggie, so that is a total of 7, and I am picking 3 of those. So 7 choose 3, and calculation comes out to 35. So that's the type of thing. You go in your calculator, and there's the option that says NCR, and that would be the 7, choose 3. The next one is kind of a compound version of that. So I have 10 boys and 12 girls, and how many committees of 2 boys and 3 girls can be formed? Now, because I'm just going to name the 2 boys and the 3 girls, and the order doesn't matter, again, this will be a combination. If, however, I were to state that out of the 2 boys, one is president and one is vice president, that changes the total number of outcomes, and that would be a permutation. So in this case, I'm going to end up taking, out of the 10 boys, I'm choosing 2, times out of the 12 girls, I am choosing 3, and you can put that in the calculator as separate numbers, but it comes out to 9,900 different committees. So those are just the first combinations and permutations. Now we'll go on to the ones involving some repetition. So how many more ways can 4 people arrange themselves in a line rather than a circle? So the reason this is different is because if they were in a line, it would look something like this, where there's 4 options for the first, 3 for the second, 2 for the third, and 1 for the fourth. And that would be 24 different ways to arrange people. However, if I arrange them in a circle like this, that is the same rotation as if I were to arrange them like this. So what happens is there's a repetition here. So the formula is we just take the number of people, subtract 1, and do a factorial. So what I would do is 3 factorial then, and that would be 6 ways. So what you would want to do, because it says how many more ways can they arrange themselves, is subtract these 2 values. So 24 minus 6 means that there are 18 more ways that you could arrange people in a line rather than in a circle. For the next one, what I'm going to do is look at how many letters there are in the word Cincinnati, and then we'll look at all the repetitions. So first of all, there are 10 letters there. So if they were 10 different letters, I would say that we have 10 factorial ways that I could arrange the letters, but because I have repetitions, it's going to limit the number of ways. So this C here is the same basically as the C here. So what I'm going to do is divide by 2 factorial. I have 3 letter I's in here, so I'd put a 3 factorial down there. And I also have 3 N's, so that's another 3 factorial. So putting this in the calculator, you can put in the numerator 10 factorial, but when you put your denominator in, I would put it in parentheses, and you're going to end up with 50,400 different ways to arrange the letters. And that's going to be the same logic as for this bottom problem too. So I have a 9-digit social security number, so 9 factorial will be the numerator, but because I have a couple repetitions in here, we'll notice that I have 3 of the 5s, so I would say 3 factorial, and I also have 2 of the 0s, so that's going to be 2 factorial. But the same type of logic that because I have the 2 repetitions in there, it's going to limit my total number of outcomes. So there are 30,240 different ways that I can arrange those digits. So then what we'll do is go on to some probability. So 3 coins are removed from a bag, and that bag contains 15 total coins. So I'm going to make a note of that. And we want to know some probabilities here. So there's different ways that I can choose the 3 pennies, and the order is not going to matter, but there are different ways that can happen. So what I want to do on my numerator is look at my desired outcome, which is choosing my 3 pennies. Now there are a total of 7. So out of those 7, I want to pick 3, but my denominator is going to be my total number of outcomes. So on the denominator, there are a total of 15 coins, and I'm choosing 3 of those. So you would want to divide this out. It comes out to 35 over 455, which is going to simplify to 1 over 13. So the next one's a little bit different because I'm mixing up my 2 different coins here. I have pennies and nickels, so that means I'm going to have a couple things going on in the numerator. So out of the 7 pennies, I want to pick 2 times. We look at how many nickels I have, which is 4 total, and I want to pick 1 of those. But again, my denominator is saying, hey, in the grand scheme of things, out of the 15 coins, you are choosing 3. So this one is going to simplify. The 7 choose 2 means there's 21 different ways that I can pull those pennies out. The 4 choose 1 means there's 4 different ways I can pull the nickels out. And then my denominator is 455, but that is going to simplify to 12 over 65. And then lastly with that, the choosing no nickels. So we look at how many of the coins are not nickels, and that is my 7 pennies and my 5 dimes. So again, let me look at the denominator. Out of my total of 15 coins, I'm choosing 3, but I have 11 non-nickels, and I want to choose 3 of those. So if you did that probability, that's going to end up being 165 over 455, but it's going to simplify to 33 over 91. So those are probabilities, which is looking at your desired outcome over the total number of possible outcomes. Alright, so what's going to be a little bit different is your odds are going to look at your desired, and also it's going to look at the ones that you don't want as well. So how this is going to work is we want to know the odds against this happening from the last problem. So what would be the odds basically of getting my nickel? So what I would want to do is take 91 minus 33, and I'm going to do that first. And what that's going to do is tell me, hey, my probability then of that not happening would be 58 out of 91. So I have a 33 out of 91 chance of choosing the no nickel, but I have a 58 out of 91 chance that that didn't happen, and that means just choosing a nickel out of that. So when I ask for my odds, what you're going to do is take these numerators and line them up against each other. So because it's odds against, I would take my 58, and I would say this is 58 to 33. And notice that if you add these two parts together, there's 91. So just to kind of give another example, let's say I had 10 boys in a class out of a total of 22 people. Well, that means that if I have 10 boys, that means that 12 of them are girls. And if I wanted to know my ratio of boys to girls, I could say 10 to 12. So it's got kind of a similar logic there, where if I wanted to look at the probability of choosing a girl, what I would do is I would say I have a total of 22 people, 12 of those are girls, I would have a 12 out of 22 chance of that happening. But if I said what are the odds of girl to boy, you would say 12 to 10. And now we're going to look at probability then of compound events. So first of all, rolling a sum of a 2 on a first toss of 2 number cubes, and then a sum of 6 on the second toss. So I think about how many ways that I can roll 2 number cubes, and that would be like if I sat there all day and went 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, and kept going with this list. So there's only one way though that I can roll a 2, and that's if both my dice were a 1 to 1. So out of the total of 36 outcomes, because there's 6 options for your first dice and 6 for your second, so 36 different ways that you can roll dice, one of those ways is going to result in a sum of a 2. But I'm also saying that on the second roll, I'm going to roll a sum of a 6. So I need to multiply my 2 events together, and I need to look at how many ways can we roll a 6. Well, I can either roll a 1 on my first roll, 5 on the second. I could roll a 5 on the first and a 1 on a second. I could roll a 3 on the first and a 3 in the second, which is the same thing as if I flip-flop those. I could do a 2 on my first toss and a 4 on my second, or I could do a 4 here and a 2 here. So there are a total of 5 different ways that I can roll a 36. So if I multiply this out, multiply your numerators to get 5, multiply my denominators to get 1,296. So there is my probability. So for the next one, we're going to switch to looking at markers. So it looks like I have 4 yellow markers, 6 pink in a box. So that is a total of 10 markers. Now we're going to be choosing these with no replacement. So I want to know the probability of randomly selecting 2 yellow markers from this box. So what I would do is I would look at how many yellow there are first of all, which is my 4 out of 10. And I look at, okay, if I take that 1 yellow marker out, now there's only 9 total markers left. And because I have one of those yellows, there's only 3 yellow ones left as well. So it shrinks my numerator and my denominator. So if I multiply this across, I would end up with 12 over 90, which simplifies to 2 out of 15. So then lastly, what is the probability if I have a bucket of number balls from 1 to 14 of drawing a multiple of 2 or a multiple of 3? So I have 14 total values because I'm just pulling the numbers 1 through 14 out of a bucket. What I'm going to do is list all of my multiples of 2's first, and that'd be 2, 4, 6, 8, 10, 12, and 14. And then I'm going to list my multiples of 3, which would be 3, 6, 9, and 12. So out of that bucket of balls, my multiples of 2 are up here, my multiples of 3 are down here. So there's a formula for this that says the probability of event A or event B equals the probability of event A plus the probability of event B minus the probability of A and B. So here's what this is going to mean. I'm going to first break this down. My probability of picking a multiple of 2, well, out of the 14 balls, I have 1, 2, 3, 4, 5, 6, 7 of them are multiples of 2. My event B is, hey, what is the probability of picking a ball that is a multiple of 3? And that's 4 out of the 14. However, we have to go through and look at how many of these balls are multiples of 2 and 3. And that would be this value right here, and it would also be this value right here. So 2 out of my 14 are already picked. So they're already assumed within these first 2 calculations. So I have to subtract that out. And if I do my math correctly, I would add my first 2 and then subtract, and I would get a probability of 9 out of 14. So then we got our last ones. So with these ones, conditional probability. So this is given that one event already occurred, and what it's going to do is increase your chances of another event happening. So the sum, or I'm going to find the probability that the sum of the numbers shown on the cubes is less than 5 if exactly one cube shows a 1. So what you want to do is go through, and what you're going to do is take your probability of your desired outcome over your probability of the event that already occurred. I missed an R. Let's put an R right there. Okay. So, how many ways can the sum, how many ways can I throw 2 dice? So I'm throwing 2 number cubes. That's what it says in the directions. How many different ways can I throw 2 number cubes and show exactly a 1? So what I'm going to do is just write out all those number pairs. So it says exactly 1, so that means that my 1 and a 1 does not count. So I could roll a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, 1 and a 6. I could have a 2 and a 1, a 3 and a 1, 4 and a 1, a 5 and a 1, and a 6 and a 1. So I have 10 different ways out of the 36 different ways. 10 of those combinations would give me a number where I have exactly a 1 in there. So it wants to know then how many of those have a sum that is less than 5. So again, there are a total of 36 different ways. What I want to do is go through all of these and circle the ones that have a sum that is less than 5. So 1 plus 2 is 3. 1 plus 3 is 4. But then 1 plus 4 is 5. So that's going to be greater than, that's going to be greater than 5. So that's not going to work. I have a 2 and a 1 that's going to add up to 3. A 3 and a 1 that's going to add up to 4, so we're good. But then again, 4 and 1 adds up to 5, but I'm not looking for that. I'm looking for how many sums are going to be less than 5. So 4 out of my total 36 were less than 5. If I simplify this, I'm going to end up with 4 over 10, which is going to simplify to 2 over 5. So again, I'm going to follow that same kind of formula for my denominator here, for part B. The numbers on the cubes match, given that their sum is greater than or equal to 5. So what I would do is go through all of my 36 combinations and look at how many of the sums are greater than or equal to 5. Well, that is a majority of them. So if I were to write out all 36, I'd be here for a while. And what I would realize that 30 of the 36 are going to have a sum that is greater than or equal to 5. So what you would want to do is look at, out of all of those, how many have matching values. So for example, if I roll a 3 and a 3, or a 4 and a 4, a 5 and a 5, or a 6 and a 6, notice that my sum here is greater than 5. My sum here is greater than or equal to 5. Here it's greater than or equal to 5, and here. So I have 4 different ways out of 36 that not only is my sum going to be greater than or equal to 5, but I also have matching pairs of cubes. So across the denominators here, I end up with 4 over 30, and that is going to simplify to 2 out of 15. Which again, let me bring in a prior concept real quick. If I were to look and say, what is the odds of this happening? Well, 2 out of 15 times I would be successful, but that means 13 out of those 15 times I would be unsuccessful. So if I were to ask for what is my odds of this happening, you would say 2 to 13. So quick review then, going back all the way to the top. Okay, so we started off with permutations and some combinations of numbers, figuring out how many ways you can order things. Then we looked at the repetitions with permutations and the circular ones as well. And then we briefly talked about probability and odds. And then we went into compound probability, which was using the words and or. When we had and, we multiplied. When we had the or, we followed this formula. And then we went to conditional probability, which is where you're given one event that went on your denominator, and out of those outcomes you looked at how many of your desired there were, and that made your numerator.